A ball starts to roll down from the peak of a frictionless hill before rolling over another hill without leaving the ground. The height of the first hill is 2 meters, and the height of the second hill is 1 meter. Determine the velocity of the ball at the peak of the second hill. Now we're going to apply the conservation of energy to solve this problem. One reason that we can apply the conservation of energy is because we know that the ball is changing potential energy and changing kinetic energy. Change in kinetic energy is equal to the change in potential energy. This is true whenever there is no friction involved, no work due to friction. Another way you might see this equation written: T1 plus V1 is equal to T2 plus V2. T represents the kinetic energy, V represents the potential energy, and 1 and 2 represent states 1 and state 2. So in this problem, this would be state 1, and this would be state 2. Anytime there's some sort of complicated path, I always recommend trying to solve the problem with a conservation of energy approach. We don't know much about the geometry of this path other than the two heights at the two positions. Since we know that the ball starts from rest, we know that the kinetic energy at point 1 is equal to 0. We want to know the velocity at point 2. So let's recall our definitions of potential energy and kinetic energy. So potential energy is equal to 1/2 times the mass times the velocity squared. Potential energy is equal to mass times the gravitational acceleration times the change in height. So if we rewrite our first equation, we have mg h1 equals 1/2 mv2 squared plus mgh2. Now you'll notice that we weren't given a mass of the ball in the problem statement, and that is very telling because the mass actually doesn't matter in order to solve this problem. If you note that each term in this equation has a mass term, which means we can divide that out commonly amongst each term, and we're left with gh1 equals 1/2 v2 squared plus gh2. I'm going to rewrite this equation and flip the sides of each term. Alright, so in this, we can factor out a g from these two terms, and then we're going to multiply by 2 and then take the square root. So v2 is equal to square root of 2 times g times h1 minus h2. I'm going to rewrite this over here. I'll just move this. So v2 equals square root of 2 times 9.81 meters per second squared times 2 meters minus 1 meter. pull out my calculator. It's going to be the square root of 2 times 9.81 times 1. And we are left with an answer of approximately 4.43 meters per second. So there you have it. That's how you can solve a problem like this using the conservation of energy. If you found this video helpful, be sure to like, share, and subscribe to help this channel grow. Please comment down below any questions or topics that you're interested in, and check out this playlist with other dynamics videos. Thank you for watching, and have a great day.